Okay, so once students have a strong foundation in using that concrete model, we're ready to move on to a representational model. So representational usually means pictorial or drawing it out. For fourth grade, you can see that by using graph paper, it very closely resembles the base 10 blocks that we were using when doing the concrete model. So we are still going to use the same problem, and actually I will write it up here. We have 12 times 23. Okay, we are going to use the same problem, and now we are going to do that problem using a representational way of learning. All right, we're going to draw it out. So you've already been talking to your students about with tens and ones and decomposing numbers. And so we're going to start again with the 12. And we know that a 12 is 10 and 2. So when I draw that, I'm again kind of building my frame. I'm only going to do this outside edge. So I'm going to start with the 12, and I am going to build my 12. I'm going to draw or line 12 units here. So I'm going to start at the corner, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I am not going to close this off because, again, I'm trying to represent an area. I am building a frame. So I have 10. So this line, this segment here represents 10. But my number is not 10, my number is 12. So I'm going to use a different color just to help us keep this all visually organized. And I'm going to add on my 2 more units down here. So this line segment represents 2. So now I have 10 and 2, which gives me 12. I am going to model the same thing for my frame across the top. My frame across the top, I have 23. So I'm going to want this to be the same in color. So I'm going to count out 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It is always a good idea before you label to recount because sometimes we can get distracted and maybe count wrong. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. My line goes here. So I am going to show that this represents 20. However, my number is 23. So I have to account for those 3 more units. So this line segment here is 23. Oh, I'm sorry, it's 3. So now the total of that line segment is 23. As with anything, we are still building area. So we represented that with the base 10 blocks, and now we're representing that on graph paper. So you can talk to students about how are we going to build this area. And this is not to scale, but just to kind of remember that it's 10 by 10s is what we built when we did our concrete model. So I'm still going to keep my 20 by my 10 because those are my tens place. Those are my whole numbers. So I'm going to go ahead and close off this area. And I'm only staying within my 20 by 10 or my 10 by 10 area here. So now I have 20 by 10. Okay, so for this model, again, remembering that kids now have a strong foundation in that concrete model that you've built with base 10 blocks over and over and over. I want to recognize this whole area of 2 by 20. I'm building on what they've already mastered with their concrete model. So when I close off this area, I now have a space that represents 2 by 20. I'm going to do the same thing over here for my 3. 3, it's not 3 by 23, so I'm not going to go all the way down. I'm going to keep my place values whole. I'm going to use my tens and my hundreds. I'm going to use what I know about my rods, and I'm keeping those place values. So now I have 3 by 10. So I'm going to close off that area. And again, I still have, it's not a complete area because I still have this that's unaccounted for over here. So to close my area completely and complete this model, just like we did with the base 10 blocks, I'm going to close off this corner. It is at this point that you're ready to start building on what does this mean mathematically? What are these mathematical equations inside each of these areas? So for this larger area up here, the space represents 20 times 10 or 10 times 20, however students see it. So I'm going to write 20 times 10. In my red areas over here, we'll start at the bottom. It doesn't matter. Start wherever the kids want to start. I have an area that is 2 by 20. So multiplication, I have 2 times 20. Again, it does not matter that I started with the 2 this time, and on the top part I started with the 20. We know that with properties of multiplication that we can flip those numbers around. It's not going to impact the answer. What is important is what do the kids see? In this area over here, I have a 3 and a 10, or I have 10 by 3. However, I'm going to write 3 times 10. And in this bottom corner down here, I have 3 by 2. So I have 3 by 2. Students then should very easily be able to do these. These are mental math problems that you're practicing on a daily basis, your number talks, your number warm-ups, all of those things. Students know very quickly that 20 times 10 is 200. Students should know very quickly that 3 times 10 is 30. 2 times 20 is 40. And 3 times 2, excuse me, is 6. So the answer is the sum of all of these products. So this model is sometimes referred to as area. It's sometimes referred to as partial products. It doesn't matter. This is building what students know about how numbers work. It's building their number sense. So to get our final answer, you could add these all up. 200, 40 plus 30 is 70, so 270. And then again, we have our 6, so 276. It's representing the same thing that you saw when we did the base 10 blocks. As students progress in their thinking, you can move away from grid paper. When they start to look at how coordinates work and how graphing works, area model is still represented sometimes just by a box. And again, if I'm looking at the problem 12 times 23, I'm going to use this model just to show you how you can push students even further to become more efficient with this model. So if I had 10 and 2, and I have 20 and 3. So again, I'm decomposing those numbers, 20 and 3, 10 and 2. I can then multiply at the intersection. I'm sure they've used multiplication charts. Excuse me. I'm sure they've used multiplication charts where they are intersecting to find an answer. This is the same thing. So if I have 20 times 10, I have 200. If I have 10 times 3, where this intersects, I have 30. I have 20 times 2, which is 40. And I have 3 times 2, which is 6. When I add them up, 276, same answer. So being ready to push into the next level, even within representational, you don't always have to stick with a model that looks like the manipulatives that you used. But keeping things organized visually for students, that is what's important, and helping them progress from a more concrete model to a more representational model before moving into an algorithm.